We are at the Hasli Ecological Station, and this station is part of the Institute of Ecology and Evolution of the University of Bern. We are investigating how climate change affects terrestrial biodiversity. And to do that, we have set up a long-term outdoor experiment where we're examining how climate change, such as warming and drought, and particularly extreme climatic events like heat waves, summer droughts are affecting plants, microorganisms, invertebrates, and more importantly, their interactions. In our 40 mesocosms, we simulate 4 kinds of temperature and 2 kinds of drought. And these scenarios represent extreme weather events or extreme climatic events. For that, we simulate heat waves, and then we also simulate extreme summer drought. So we want to predict the future of biodiversity by bringing the future in present. 90% of terrestrial biodiversity is plants, invertebrates, and microorganisms. And we want to understand how all these 3 are responding by measuring many different things related to these 3 groups of organisms. So we measure plant biomass, different traits of plants like how thick their leaves are, how much they are photosynthesizing, how much they are respiring. And we have actually sensors which measure soil temperature, soil water every few minutes. So we're generating a lot of data to understand how biology, how biodiversity is changing in our mesocosms. So one of the things that we are seeing in our experiment is a delayed response. So what we are seeing is a lot of plant species do well when there is climate change. But when you stop drought, you see a delayed response. And we call this concept ecological debt. What happens with a lot of our plants, a lot of our invertebrates, a lot of our microorganisms, they sort of overcompensate during the stress, but when the stress is over, they do not have enough resources to pay that debt back. If you have a system where you have a lot of interacting organisms, all accumulating ecological debt, then you will see negative consequences overall on the interaction and therefore on biodiversity. The knowledge that we are generating from our experiment will let us know how the biodiversity will look like in the future. We want to inform with our knowledge how we can protect biodiversity by generating, of course, some fundamental knowledge, but that fundamental knowledge has a very high societal relevance.